Okay, today we are going to learn work energy power. Most important question for 8 marks. Law of conservation of energy. Law of conservation of energy in the case of a freely falling body. Now we are going to discuss the 8 marks question. Law of conservation of energy for a freely falling body. Okay, we are verifying the law of conservation of energy for a freely falling body. Now, what is the statement of law of conservation of energy? Energy neither be created, energy neither be created nor destroyed. Nor destroyed. It is transformed. It is transforms from one form to another. The total mechanical energy of the system is constant. Now this is the statement of law of conservation of energy. Okay, right. Now we are verifying in this case of a freely falling body. Verification of law of conservation of energy in the case of freely falling body. What is the meaning of a freely falling body? Means when we are not applying any force on the body, if it is left freely from certain height, then that is considered as a freely falling body. Its initial velocity is always zero. Now I am drawing a one line for the freely falling body. Now we are considering that this is the mass of m. Okay, it is freely falling from certain height of h. Okay, now we are taking that to verify the law of conservation of energy. We are taking the 3 points. At every point it becomes constant. Then indirectly we are verifying the law of conservation of energy. Now we are considering that this is the A position, this is B position, and this is C position. Okay, now it travels some distance of small h at this point. Small h at this point. Okay, now at A point, at point A, the body is at a height of h. Then potential energy U at A is equal to mg into height of the body. Height of the body. Now we are considering that at this point mg into what is its height? H we are considering. Okay, height is equal to h. So U at A is equal to mg h. At point A, body is freely falling. Body is freely falling. That is, its initial velocity Va is equal to 0, I am considering. Now therefore kinetic energy at A, K at A is equal to half mVA square. That is equal to half into m into VA. VA is, we are considering that here 0. So 0 square Okay, 0 into something 0. Now K at A is equal to 0. Now in the same way, now therefore we have to find the total mechanical energy. Now therefore total energy at A is equal to potential energy at A plus kinetic energy at A. That is equal to U at A plus K at A. U at A is how much here? LGH. K at A is 0. Therefore, total energy at A is equal to mgh. Followed? Now, we have to find at this point also B. Now, we are going to point B. At point B, to reach this point B, okay, it is traveling some h distance. Then, what is the height of the body? H minus h. Capital H minus small h. Now, therefore, at point B, body is at a height of h minus h. Now, therefore, the potential energy at B is equal to mg into height of the body. That is equal to potential energy U at B is equal to mg into h minus h. Now U at B is equal to mg h minus mg small h. Okay, now we get the potential energy at B point. Now we have to get kinetic energy. Now to reach point B, body travels small h distance. Now here A to B, it is traveling small h distance. Now therefore, initial velocity u is equal to 0. Okay. Now how much distance it is traveling? H distance it is traveling. If it is freely falling, then its acceleration is equal to plus g. Okay. Next, final velocity v is equal to, I am considering that at this point vv. Okay, at this point we are considering that vc. vv, that is equal to how much? From v square minus u square is equal to 2as. V is vb square is equal to, minus 0 square is equal to 2 into plus g into h. Now by this equation vb square is equal to what we can write? 2gh. Now earlier we get vb square is equal to 2gh. Now therefore, kinetic energy at point B is equal to half mvb square. Okay, kinetic energy K at B is equal to half into m into vb square. Already we got that, 2gh. These two get cancelled. Kb is equal to mgh. Okay. Now therefore, total energy at B, okay, is equal to potential energy at B plus kinetic energy at B. That is equal to U at B plus K at B. U at B we got mg capital H minus mgh. K at B we got here mgh. This one get cancelled. Total energy at B is equal to mgh. Now we are considering this is the equation 2. Now at point C, at point C, body is on the surface of the earth. Body is on the surface of the earth. That is height h is equal to 0 we are considering. Now therefore potential energy at C is equal to mg into height of the body. Potential energy U at B is equal to mg into 0, U at B is equal to 0. Now we have to find the kinetic energy. To reach C point, body travels, okay, capital H distance and having VB velocity find. Now initially it is 0, acceleration is plus g. How much displacement h? V is equal to VC, that is equal to how much? Now therefore from V square minus U square is equal to 2as, Vc square minus 0 square is equal to 2 into plus g into h. Now Vc square is equal to 2gh. No need to find the Vc. Now therefore kinetic energy at C is equal to half mvc square, that is equal to half into m into 2gh. This 2 get cancelled. A at C is equal to mgh. Now therefore total energy at C is equal to U at C plus K at C. Total energy at C is equal to 0, this become mgh. Now therefore total energy at C is equal to 0. Now total energy at 0, mgh. This is equation 3. Equation 1 we got mgh, equation 2 we got mgh, equation 3 we got mgh. Now therefore from equations 1, 2 and 3, total energy at A is equal to total energy at B is equal to total energy at C. That is total energy is equal to constant. Total energy is equal to constant means indirectly we are verifying the law of conservation of energy. Now therefore law of conservation of energy is verified. Thank you.